turn off it.
Okay. Don't worry, don't worry. I thought it was on my
Did you
side.
hear it?
Yes. I heard that in him factor.
We got ICU to Windows, so
Okay. So, Professor,
sorry.
So everybody's here, right?
let me check.
No, sir.
Okay.
No, Tarek is not here.
Yeah.
Our other students
Musa.
are not here. Yes, let me call Tarek and check.
I guess Innocent is also not here. And Tariq,
Yes,
Innocent.
Yes, yes.
and Kumsa. Yo, bro. Yeah, join the class. Okay. Mhm.
Okay,
Uh,
so they will join, right?
yeah, he's joining. He said he would join. So let me text
Okay.
Kumsa and Innocent to on WhatsApp.
Yeah. So we can start. Uh, we have some other operations and simple comments that we need to talk about them, and later on we will try to write a code together. So we have a matrix A similar to that. Can you see that?
Yes.
Yes.
Okay, so I guess the last comment that we talked about was sqrt. Then let's try another. We also introduced rand-n, which is a Gaussian normal distribution, random numbers. Then we also introduced rand, that is with uniform distribution. So
everyone.
hello.
Sorry for the delay.
Yeah, no problem. So we have another common apps, which is for taking the absolute. Okay. Then we have max that we already introduced that, but we can use different. We can use it in different way, like a and one, for example. So it gives you the column-wise maximum when you put one here, or you can put two, and it gives you the maximum per each row. And you can do it also with for minimum, for finding the minimum. Or
Please, Professor, could you go to the top?
Yes.
oh, okay. So you cannot see the.
No, me where the maximum is, where you started with the maximum.
So this is the last comment that this is you already saw that. Okay. This is the maximum of A per row, per each row. Okay. This is A and this is the maximum. Can you see that?
Yes.
Yes.
Okay. Then you can also do it for minimum, or like that. And you can also write min. You are already familiar with the min function, which is the average. And if you put min A, so this is A, and this is mean A. So this is the column-wise mean average. Okay, or you can do it like that. So this is the mean, the average of each row. And if you want to, you can simply write minus A. It's similar to multiply A by -1. Okay, then what else? So you can also write sum of A. Okay, this is summation of the, so let me show you A again. So this is A, and sum A is just summation over the columns. Okay, you can also write let me do it by a vector. It would be much easier. A is equal to, for example, this one. This is a horizontal vector, right? Then sum A is just summation of all the elements. You can also try product of all the elements, and we can more complicated vector like A plus rand of size A. Okay, this is a vector, a horizontal vector. You can try floor A, which rounds all the elements down, or you can try sail A, which rounds them up, and just to compare it with floor. You see the difference? And you can also try round A. This rounds toward the nearest integer. Okay, so these are the main operational commands. You can also, when you want to work with your data, you need to have access to them. So we have a command like pwd. This is current directory. Okay, you can assign it to a variable. Pwd is the command for common directory, and crd is where we saved that. So crd is this one. Then you can you have command cd for changing directory. For example, let me go to my desktop. So this is how it works. And now pwd says that I'm in desktop. Okay, then you so we want to get back to this directory, and we already saved the address to crd. Okay, so when you want to use cd change directory with the address by writing the address, this is the way that you have to use it. But when you want to change directory to an address that is already saved in a variable like crd, you have to use this format, this syntax. Okay, and now we are here again. Okay, then we have command ls, which lists all the file in the directory. Then we have a command mkdir for making a directory. So we want to make a folder, and let's call it a test. Okay. It says that the directory already exists, but anyway, it can produce a directory. And okay, so when we do ls again, you see test, and then a useful command is dir, for example, to see if you want to see if test is a directory or not. And you see that the answer is yes, logical yes. And then, for example, we already saved our current directory to crd, and if we try this dir crd, we'll get yes. And okay, for example, we can try it with a directory that I think we don't have it there. So it's dir test, and you get 0. So you don't have such a directory. So then another command is copy
What's
file.
happening? We cannot hear you, Professor.
Oh, you cannot hear me? What about the others?
I can hear you.
I can
Me,
hear
I
you.
can
Yeah,
hear.
I can hear you from here.
Okay, Tariq, probably the problem is with your headphone or something like that, because the others can hear me. Tariq, can you hear me?
Yes, now I can. Sorry.
Okay, yeah. So we have another command, copy file, for copying the files. And for example, let me copy a file so this is the current directory where we already are, okay? Test.txt, and we want it to be copied to directory test, which is in current directory. So this is copy file. Then what else? Okay, we have another command called dir, dir. So let me introduce another. So is equal to dir. Okay, so this is what we already produced. So it's composed of 27 structures with 6 fields. And what is inside that? So we have name, we have folder, we have date, we have size. So is it a directory or not? You are familiar with this one, is dir. And for example, if we want to see just the names, cdr dir dot, this is the syntax, okay? Name. It prints all the names, okay? Or we can also try cdr dot cdr dir dot folder to see the folders, okay? If you want the absolute address to a file, you have to combine the folder and append it with you have to append the folder address with the file name, with the name. Then we have, for example, let's take a look at that. And for example, 11. or one of them that is a folder. Okay, this is a folder. So let's try, it's 10. We want to specifically take a look at this one, CDR dir, then 10 dot name. This is how you can have access to one of them. Okay, this is the name, or is dir. It's yes, it's a directory. And what else? Okay, so we want to write a for loop, and what is the format for loop? So in the we will learn how to make a for loop, and in the meanwhile we will learn how to produce, how to take a look at the files that we already have. So we can write for I equal to 1 to length of CDR underline dir. So what is this? This is a general format of for loop. Okay, and your counter is here, I, and it starts from 1 and will continue to reach to the length of CDR. And you are already familiar with length, and the length of CDR is 27. Okay, so I will be 1, 2, 3, 4, and it continues to 27. So we have each for loop should end with should terminate with n. But we want to do something else here. We want to add a if condition here. For example, we say that CDR, if CDR dir of I, so we are scanning all the fields in CDR dir. I dot is dir. Oops. Why is that? Is dir. So, for example, it goes to the first field, to the first one, which is here, to the first structure, which is this one, and then goes to this one, and this one, and this one, and this one, and this one. Okay, and if that is a directory, then the condition is satisfied, and then we want it to, we define a string, so we are using all the comments that we already learned. To strcat is another command, and using strcat you can add two different strings together. Okay, for example, here we want to combine. You remember that when that I told you that when we want to write a string, it's better to use this one. The reason is that we, at some point, you need to have this one in the middle. Okay, let's make a combination of the strings then, for example, I, then that's name, and then we combine that. So this is the format, this is the syntax for strcat. We are combining this string with this string. It's already a string, for example, name. Okay, this is a string, but in a variable. And then again, something like that, you will see the result. And again, with, for example, is a directory. Okay, this is a string. and we combine all these string together. So then this, and we will store it in a variable called str, and then we will show it, we will print it. So up to here, we have a for loop from 1 to maximum size of CDR dir, and we introduce if a condition. If it is a directory, make this string and print it, okay? Else, which means that, so if this condition is satisfied, these two will be executed. Otherwise, we make another string. I just copy that and paste it, but it's not. Oops. I made a mistake. Okay, so we can edit it now. And then again, this string. And this is the end for the if right here, and another end for the loop. This is not will be a correct one because the string for both of the conditions are the same, but we will edit it again. Okay, so CLC and everything is here in comment history. So we copy up to here and paste, but this one need to be edited. Okay. Is not a directory. Okay, and is the string and for the if condition and end for the for. Okay, so it's, for example, here, this is a directory, this is a directory, then oh, I forgot a semicolon here, so just forgot this str. And for example, this is a file, this is not a directory. We can take a look at that here. For example, this one, and you see that is directory is 0. This is not a directory, or this one is not a directory. Okay, so this is a for loop, and okay, we can somehow manipulate it again. We can write it like that, and if CDR again. That's dive. And so this is how, when you want the logical conditions, you can use two ands. Okay, it means that if this condition and the next one, both of them are satisfied. Okay, you remember that we made a directory called test. So we say that scan all the directory, and if the directory is, if the file, if that one is a directory, and we have a command strcmp. This is for comparing two strings to each other. So it has two fields. One is the name of the directory, and the other is test. It returns 1 or true if these two, the a string in the variable CDR dot CDR underline dar I dot name is the same as test. Okay, if this is true and this is true, then it whole the condition is satisfied. Okay, then we can make the string again like we already made it, and this str, and then we can also this I, we want to see what is counter, and then we can, for example, do some other things. We can cd to that directory that we already know that the directory's name is test, because we compared that and the condition is satisfied. And then, for example, we can check if it's really the directory is changed to test. So pwd, and then, for example, ls to see what is in that directory. So we need an end here for the if condition. Okay, and another end for the for. What was it? Okay. That's right. Okay, one end and another. Okay. We check and we see that test is a directory. It's 20. Here you see that 20 is test. And then this is, we changed the directory, and now we are in test because this is the output of PW. And then we took the ls. Do you remember? We copied a file with the name of test.txt to the directory test, and ls shows that, okay, this is there. So the other command is this one. It will change the directory to the parent directory. And so that's it. When we want to work with MATLAB, we usually don't use this command window. Just for very simple stuff, we can do that. But we usually write a code and save it in a file with .m extension. So to do that, you need to press this one, new script, or use any kind of text editor to write your code, and then you can just save it as .m file, and you can run it in MATLAB later. So let me make a file, a new script. I guess you cannot see that. Share. Okay. No. So can you see whole my desktop now?
Yes.
Yes,
can
yes.
see the command window, and you can see this window. When I press this button here, this file is generated, but it's not saved. So I'll save it with a name, I don't know, D_2021. .m, you see, this is the point. Okay, this is saved. So all the things that we have done here in command window, you can do it, you can write all the comments here in this file, and then you can simply run the script like that. So when we usually write a script, we start with DLC or with clear. You are already familiar with that because we don't need the variables that are already in the workspace if you don't need them. and then you can also close all to close all the figures that are open, and then CLC to clear the command window. And then you can, another thing is to put 2% sign without space. If you put space, then it will be like that. So the percent sign is just for making comment. Okay, if you add percent at the beginning of the line, it's comment. Okay, but if you put 2% in row, then it's making a new field. It's splitting your code to different sections, and that's quite useful, and we will get back to that later on. So you'll save it and simply run it. So all the stuff is this. Hello. Okay, so this is the verb, or let me s is equal to string. So s is in our workspace and our command window is like that. And let me open a figure, and a figure is opened here. So this is the situation now. But if I run this code, the figure is closed. The screen is, the command window is clear, and the workspace is clean. Okay. So did you, okay, the next thing that we can do is to load the data. Do you have the file that I sent you? Did you download it?
Yes, yes.
Okay, so do the things as I do. So we can load our data, but load is a command that you can use it when you have your, like a matrix or a vector stored in a file without any string, without anything else. Okay, this is just numerical. Then you can use load, and what was the name of the file? Then it's, I guess, 33. That's what a name, I don't know why didn't I? Okay, and tab, okay. So as soon as you reach to some point that the file is just unique, you can press tab and it will be autofill. Okay, so this will load our file. Let me show you the file first. Okay, this is the file, right? This is the file that you already have.
Professor,
Yeah.
We don't have to specify the path where the file is.
Yes, I'm just assuming that you are in the directory that your file is. Otherwise, you can do that. So let me do that. But first of all, take a look at the file. This is the file, and it's composed of one column with 15,100 rows. Okay, so this is a vertical vector of 15,100 rows. Okay, and I have, if I load it, okay, but before that, let me do that. It's a good example. For example, PW, we are here, and you can add the absolute address to the file. If you don't add the absolute address to the file, then it's just looking for that in the current directory. Okay. CLC. So let's run the code. Okay. It's already here. It's loaded, and you can see that its size is the same as what we had and the value. So this file is a sort of time series related to a horizontal component of a strong motion sense record. Okay, so we already loaded that, and you can also try size You can check the size of that. And be careful because it's sensitive to the capital letters or small letters. So for example, if I don't put capital here, okay, and run the code, I'll get an error. You see, recognize function or variable time series, because this T should be capital. I got an error in line 7, and if you click on that, you will see where the error is. But if I put capital T, then run the code, okay, the size is printed here. Okay, are you following this, guys?
Yes.
Yes.
Sure,
Okay.
sure.
So we can define a variable called SF and put the sampling frequency of the time of the record in that. SF, so the sampling frequency is 200 hertz. We can define a variable for sampling period like that. Okay, then we can also define another variable. So this is a sort of practice of all the commands that you already learned. You can put ns equal to length of the time series. So this is the number of points that we have. This is the length of that, and we will use all of them. Then you can also define the duration of your record. When you know the sampling frequency and when you know the length of the time series, you can also define the time domain. Okay, in the file that you already have, you have just amplitude values, but you don't have time. Okay, so we can define the duration of the record by multiplying number of samples by st minus st. Okay, this is the duration. And let's print it out. Let's run the code. So you see that this is the size of your time series, and the length should be the maximum of this one, ns, and the sampling frequency, we said that it's 200 hertz, and then the sampling period will be 0.005, and the duration of the record is more than 55 seconds. Okay, so let's try with defining a time vector, which starts from 0. You're already familiar with all these comments. Okay, and with a step of st, which is sampling period, the distance between two samples, and it continues to the end of the record duration. Okay, and run the code. And here is t. Its length is the same as our amplitude file, and it continues to here. And this is the duration. It starts at 0 and it reaches to duration. Then it's far better to have all the time and the amplitude in the same file. Okay, what we can do is to make it like time series of, the second column of time series is equal to time series. Okay, what would be the result? Now you have two columns in time series. Before that you had just one, but you just copied the second the first column also to the second column. Okay, then we can say that the first column, we want the time to be in the first column. Okay, then we do that. Now, if I run the code and look at the time, so you see that this is time and this is amplitude. Everything is in the same, in one variable now. And so we don't need t anymore. So we can, I'm just practicing all the command that we already learned. So clear t will clear the variable t, which is already stored in the first column of time series. Sorry. So if I run the code, t is not here in the workspace. Okay. So up to here, we loaded our file. We defined our variables, and we defined a new variable containing t and time and amplitude. And so seems that we are done with this one. So we can open a new section like here by adding this sign. And when you see that when I click on that, it's clear that's where I am. So here you can also define for your just information to make the code easier. This part is for loading, and let's try plotting here. Okay, this is a command. Then, this is a comment. So we want to plot our record. What we can do is to first open a figure. Okay, then we can, okay, let's do it with subplot. We have, when you use just figure and plot something, you will have one figure and it will be plotted there. But there is another command, subplot. Okay, and it divides your current figure to like a matrix. For example, we will try with 3 by 1. So you will have 3 figures, 3 multiplied by 1 figure in your, you will have 3 axes in your figure, and there you will see that you have 3 rows and 1 column, the order of the axis. And this is the first one. So this is m by n figure, and this is the first one. Then plot, we already stored everything to this one. We want to plot time, which is in the first column, versus amplitude, which is in the second column. So you see, this is the command. X versus Y, or time versus amplitude. And then the marker that we will use to plot is, you can simply write -R. So it means that it's a line, and R stands for red. This is the color. You will see how does it look like. So let's try. Run the code. And this is what we will get. Did you also get the figure? Did you get the same figure?
For me, I was trying to get what you are doing, so I couldn't follow doing it. Because
yeah, try to do it. It's quite important, because now we are not just, we are trying to write a code together. That's the point.
Oh, okay, okay.
So try to do everything that I do.
Okay.
So anybody did this or?
Okay, I get it.
So you have the figure.
Yes.
So this is the figure, and we said that we want the figure to be divided to 3 axes, and the first and the 3 axes is like the 3 rows and 1 column, and the first row is this one. We plotted that with red and line. So this is our time series. This is our strong motion record, and we simply plotted that. Okay, let's do some more sophisticated. So this is acceleration. We can add X label. X label will add a label to the X axis. This is the command. And so what is the X axis? Of course, it's time and it's in second, right? We can also add Y label. And what is the Y label? This is acceleration, and the units are gal. Okay, and let's run it again, run the code. So one thing that you can do is when you don't want all the comments to be, you don't want all the code to be run. Okay, so let's try it. We run it, and now you see that the X axis and the X label and Y label are also added. Okay, but at some point, maybe you want this part of the code to be executed. You can simply activate it by clicking everywhere and press Control Enter together. And this part of the code is run. The other parts, they are not, these two are not executed. And how we know that? Because this figure, the first figure that we produced is not closed. If this part was closed, as I do it now, you see, everything is in the workspace is clear, command window is clear, and the figures are closed. Okay, so did you guys, everybody did this one or not? Hello?
Yes, yes.
Yeah, apart Simone, I want everybody to do that. So are you trying or?
Yes, we are trying to do it fastly.
Yeah. So did you face any problem? I need to hear you guys. Dung, did you do that?
No.
Or if
Yeah,
you
yeah,
faced any problem? Okay, please let me know. Okay, you are done and you got the figure, right? I guess you are muted.
Yeah. Yes, sir.
So you
it.
got the figure?
Yes.
Okay, perfect. Yakubu?
Yes, I'm typing it. I'm the
Oh,
one
you're
who told you.
typing.
Yeah, I'm the one who told you I was going
Okay,
to like,
you don't need to do anything else. You just need to do this part, this one.
yeah, yes.
And Tariq?
Yes, I did it.
Okay, you got the figure. Please let me know. I need to know your that if you are done. And so Innocent.
Yeah, I'm still typing.
Okay, Kumsa.
I'm using my mobile. My computer is stuck. I will do later. No problem, Prof.
Okay, you're not doing that because you're using your mobile. Okay.
Yeah.
Okay. So seems that Yakubu and Innocent are doing that, and let me know when you are done with that. So this is acceleration, and we want to integrate and produce the velocity and displacement. And we already know that we can do it by numerical integration in time domain. So we say that velocity, let me add something here, velocity.
This excuse me.
Yeah.
My command line, I don't know. Whenever I type the first line, then I want to move to the second line. Then
Okay.
I press enter to move to the second line. It tries to run. It tries to run, then it will display error.
No. Share your screen. Let me see.
Okay, I'm using this one. Let me rewrite this for you.
Oh, that's quite easy.
Whenever I type, I want to move to the second line, then it will
So
like
are
it
you
will
in
try
the
to run.
command window? Are you still in the command window, or you are?
Yes, I'm in the command window. I'm in the command window. So whenever I try to
No. You should not do that in the command window, as I told you. You have to go to the editor window.
Okay.
So I cannot really see.
Okay, so I've clicked the new, so I've opened the editor window now.
Yeah, everything should be in the editor window because we are making an .m file.
Oh, .m file, yes.
Okay.
Okay.
And if you wrote everything, then you can simply copy that.
Copy.
To there.
Okay, thank you.
You're welcome. Then let me share. Okay, so you can see my screen.
Yes.
Okay, so we want to define a velocity. We want to integrate the acceleration to velocity, right? So the first, the command that we can do that is com traps. This is the command for numerical integration. And what are we going to integrate is this is time, and then this is amplitude of acceleration, right? So I just run this part. Now we have a variable called vel, and the size is like acceleration, and it's the integration of the acceleration. Okay, it should be velocity, and we want to plot it. So for making your
Please,
life, yeah,
the function com trapez
yeah,
is for integration.
yeah.
Okay.
It's
okay.
numerical cumulative integration. So
Okay.
you can press help here simply and type.
It's a trapezoidal.
Yeah, it's exactly.
Okay.
From the
okay.
name, you can easily recall.
Okay.
Traps, and you will get the documentation. Okay. So here is velocity. I just simply copy this stuff, then I don't need to type it, and you can do the same, but you need to edit it in that way. So now we are going to the second subplot. So the last argument should change to 2, and the time axis is the same, but instead of acceleration, which is here, we want to plot velocity, and X label is the same because it's time, and then we want velocity here, and the units will be centimeter per second. And when I press enter, I control and enter just to run this part. Okay, you see that the velocity is also plotted here. Then let me try with displacement. And so now to get the displacement, we need to integrate the velocity, right? So I will change it to velocity here. And the top subplot is 3 because I want the last one. I want to plot in this free space here. And this one will be stored in a variable called this, and then this, and this is displacement, and the unit is centimeters. Okay, and I run it, and this is displacement. So I already showed you in the slides that this is happening. So it tells us that the displacement during the earthquake started from 0 and finally it reached to more than 1,000 centimeter, which doesn't make sense. Okay, or the velocity, even before the earthquake, before the arrival times of the P wave was increasing. So these are the results of noise. Okay, let's do something like change the velocity to blue. So B stands for blue and the displacement to green, and run the whole code. Okay. So let me know if you are done and if you are following me.
I've got
Yes.
it.
Yes.
Okay, Simone
Yes,
is
sir.
done. Dung, also you got the same figure. Everything is right.
Yes. So why you have to put minus before a green, blue, and red?
This dash,
Yes.
you mean?
Yes.
Yeah, you can simply try it. Let's, for example, remove this one and run it. Nothing happened because it's a line. Okay, but at some point, for example, you will see that we want to replace the marker with, for example, dash dot. You see, now it's with dash dot.
just
So this is the marker. Yeah, it doesn't make change, but it's better to remember to put it always there. So I prefer to do that like that. And another command that you can use is also grid. I don't know if I told you about that. Grid on. Okay, to see how it affects. So you see the grid lines are added to the first subplot, but the two others, they don't have grid lines. So it makes your figure somehow nicer. So I add it to all the subplots. If you run the code again, okay, this is your figure. So up to here, we have acceleration, velocity, and displacement. And please let me know if you are done with writing the code and everybody got the same figure. Yakubu?
Yes, I'm doing the plotting now.
Okay, you're not done with that.
Yes, I'm doing the plotting.
Okay, let me know when you are done. And Tariq?
Okay.
It's okay for me.
So you got the same figure. Tariq, did you get the same figure?
Yes, yes. Yes, yes.
Okay. And Kumsa said that he's with mobile phone and Innocent.
Yeah, yes, I got the same.
Okay, guys, please let me know when you are done at each stage so that I don't need to come and ask you one by one. Okay. So we are just waiting for Yakubu. So let's do some fancier stuff. We can open another figure, but this time we are not going to use these subplots. Okay. And let's call this part plotting log, for example, or whatever. It doesn't really matter. This is a comment for ourselves to see what we are doing. So we open a figure and then we plot the acceleration, exactly the same command, but instead of plot, you use another command called log. And it will plot the figure in a log like that. So you see that both the x, the horizontal and vertical both the horizontal and vertical axes are in logarithmic, and this is quite strange because you have some negative values, right? Just to recall you that how a log command will work. And we can also try another command. This is just introduction of the commands. Semi-log x. Okay, this should be better because in x-axis, in time axis, you don't have negative values, then the logarithm will not face a problem. So this is in semi-log x. It means that the y-axis is linear and this x-axis is logarithmic. You can also try semi-log but y this time. And when you don't want to use this line and you just want to make it a comment, you just need to add a person sign at the beginning, and it's commented and it's inactive. So everything is the same as the plot command, but instead of plot, you need to write semi-log x or semi-log y or log. Let me also put log for you. Or log. Okay. And if I run this one, I'll get this figure, which doesn't make sense because we have negative values in y-axis, so they're not useful. So the only useful one can be this. So did you try these comments?
Yes.
Okay.
Yes.
And then we are not going to use them, then I can, and I can comment them because these are not useful now. And just it was to introduce you that these are the comments. Then we go to the next section. Okay, at some point you do some computations and you want to write your results. Okay, you want to print, you want to save your results. So there are plenty of commands to do that. For example, we already have a new variable called time series, which is better than what you loaded because t is already here, time is here, and amplitude is here. And we want to write it in a file, and then we will use it later on. Okay, one command is to save. Okay, and you want to write it, for example, in a file called time series.mat. .mat is, it saves the, let me write it completely, then I'll explain. Okay, so this is the command. It will save the variable time series, which is 2 vector, in a file called time series.mat or whatever. I mean, you can change the name, but the extension is quite important here. And .mat is a sort of more compressed binary format. So the size will be reduced when you use that. Okay, let's do it. And to see if it's done, we will ls to see if it's really there.
Yeah, below.
Okay, it should be.
Below test.
Okay, yeah, this one. Okay, it's saved. And you can also,
Excuse me.
yeah.
Yeah, my own, I'm done typing it and I tried to run it, but I was getting some errors and
Okay, share your screen, then I can see what's your error.
okay. Share my screen.
Oh.
Yeah, who can you join by? Can you join Zoom by? Can you join Zoom by your PC? Can you join?
If I
No.
join with this PC, I can't share my screen. It will freeze.
Really?
Yes.
Because now I cannot see.
I cannot see.
Yeah. So what's the error? Just read it for me to see what. I mean, the errors are. Okay, what's the error?
Let me run it. The first one. Okay, let me read the last one. The error file OCM.line. Okay, unbalanced or unexpected parentheses. Oh,
Okay, so it means that you opened a parenthesis somewhere,
yep.
or you. Okay, let me share my screen, and then it's good also to learn how to debug. Okay, so probably the problem that you faced is something like, in your editor, you see this color over here. When it's orange, it means that you have some warnings. Okay, but warnings never stop your code from being to execute. But at some point, just look at here. If I remove this parenthesis, then it's red. Red means that even without running that, okay, red means that I have an error, and you can find where the error is. So, okay, this is red. And it's mentioned line 31 invalid syntax, might be a missing closing, okay? 31 here. And I see that, okay, one parenthesis is not closed. So probably if I don't pay attention to that and I just run it, I'll get an error here. Probably you get also something similar to that. And it said that, okay, in this file and at line 31, you got an error. And when you click on that, you go directly to here.
Okay.
And so where is your, then you can find where your error is in one of the ways that I told you. But the best one is like that. If it's a syntax error, then it's quite easy to find it like that.
Oh, okay. Okay. Thank you.
You're welcome. So we save the math file here. You can also save it in a ASCII format, but the point is that you, for example, you can try txt. Okay, so we want the variable time series to be stored in a file called timeseries.txt, and we want it to be ASCII. So this is the command. And if I run it, oops, what happened? Oh, it says that ASCII is not command option. Oh, I missed one I here. Okay, it's with double I. Oh, this one is also not.
I think that you have one C too many in ASCII.
Okay. Okay, it's done. Let's do hold the code again. Okay, and if we ls, then time series.txt is also there. And yeah, so this is another way to save the file. Then what else? Okay, there is another command, write matrix. So time series is a matrix with two columns, right? So we can use the write matrix command to save it. So this is the variable. The first argument is the variable that we want to write, then comma, then the file that we want to write the matrix. Okay, but the default and the file name should be a string. So the default format, that's the default format of writing with write matrix is a comma separated file. If I try that, for example, let's let's try it. Oh. Why? Yeah, of course I mean this. Okay. Just this is the right comment. Okay, so this is done. And if we go here and open this with any kind of editor, you see that this is a comma separated file. So the first column, which is time, is separated by comma from the second column, which is DOM. But the point is that you cannot load it, I guess. Let me try. I'm not sure. Sorry, that's txt, and then it should be like that, and put it in a variable called a. Oh no, we can load it anyway. So the other point is that when you want to write a matrix, you can also specify the delimiter. For example, as I told you, the default is comma, but you can also use tab, for example. Then you write delimiter, and what is the delimiter? It's tab. Thank you. Valid parameter oh, delimiter. Okay, so if I open it again, you see that now they are separated by tab. So this is how you write your stuff, but just to check if everything is okay, we clear let me do it in here because we don't need it in the code. So we clear the variable time series and we load it. So if you don't mention, if you don't specify the file name here like this, it will use the file name as also as the file variable. Okay, but it's always good to mention the file name and then so oops, I forgot the extension. You see that it's here. So it was writing your process stuff. And what time is it? Oh, it's quite late. So what else can we do in this? Okay, another comment is, so now we are working on processing. And we have a comment. Let me run the code again. We have a comment called the trend. Okay, the trend in its simplest way, it just removes the mean value from your time series. Okay, and let's do that like this and store it again. If your time series has a linear trend, it fits a line to that and it removes that. Okay, So this is the trend here. Then what else? Okay, you remember that I said that we need to pad our waveform padding before measuring the Fourier amplitude spectra. So to do that, we already know we already defined these parameters, and we use a command called next to POW. Next to POW2. Okay, you can see that what this command do. It will let you know that what is next POW2. Next POW. Oh, I have a 2 here. Okay, it's for it lets you know that what is the next higher power of 2, and you need it for FFT, for doing FFT. So we define a variable called number of s equal to next POW2 of this one. Okay, then what is the value? Oh, sorry. This is NS, or length of that one. Let me try with this one. Length. Okay, it's 14 now, or if I already stored that in NS. So I can simply write NS. So what else we can, okay, number of pads. So we have just one more class, right? It's tomorrow.
Just tomorrow.
Okay, so I guess, so are you done? Have you followed everything that I told you so far, or?
Yes.
So everybody saved the file and everybody loaded it again, and it was fine, right? You tried semi-log X, semi-log Y, and log.
I've been able to resolve mine.
Sorry?
I see, Yakubu. I said,
Okay.
Yeah, I've resolved mine. Thank you very much.
Okay, so great. Then I guess we cannot do much in the next 5 minutes, but let me see, what can I do? Okay, so let's try. So you already know that what is the next 2 POW doing? It gives you the next power of 2, and you use that as the power. Okay, this is the optimal length of your time series that can be used for FFT. So your current time series, the length of your current time series is like that. So it's smaller than this one. So you will add zeros to the beginning and end of your time series to reach to this length. Okay, this is called padding. And so how many zeros do you need for that? We can write n pad, number of pads is equal to, for example, round. So we need to add the pad to the beginning and to the end. So we have to obtain the difference, first of all, the difference between this one and ns, and then divide it by 2, because we need it to be added to the end, to the both ends of the. So we need 642 zeros to be added to the beginning of the time series and the same to the end of that. And probably you remember from last SP input is, we can put it, this is how we can add the numbers. We can concatenate different vectors. Okay, zeros of time of n pad and 1. Okay, this is for the beginning. And then we have our time series. And again, to the end, we need the same vector of zeros. So now time series, SV input. You see that the first 642 values are 0, and then also the last 642 are 0, and its length is what we got from next to power and what's needed by that. So then this was padding, and then what is it? Okay, let's try to do the. We can define. We can do the FFT now. We define a variable called FSP, and then we write FFT. FFT is a MATLAB command, and then we also need to detrend, as I told you, detrend, and this is our new time series that we will use it. And here we need to mention the number of the length of that, and we multiply it by ST. Okay. This is our Fourier amplitude spectrum, but we also need to define the frequency domain, and I guess we don't have enough time to do that. So please, we will continue working on that tomorrow, but please write this code and run it and manipulate it by yourself. Then you will be, we will be able to go on faster tomorrow, and I hope that by tomorrow, I was supposed to finish it today, but it seems that we are quite far from that. So by tomorrow, we will continue working on that one. And yeah, I need to change the schedule. Maybe if we can finish it, then I can also show you some shake map codes in MATLAB and everything. So hope it was useful, and then see you tomorrow. if you don't have any questions, but of course, if you have any questions, I can answer it now. I'm not that in rush for going. So you don't have any questions?
Can you scroll? I want you to scroll to this part. No. Up. Like
Okay.
go down. Go.
Which part?
I know. Go up more. Like it's too much. You just go up. I want a certain portion of where the velocity. Here.
So you're talking about this part. So this is the file that I sent you, but this is address in my hard drive. Yours could be different.
Yes, mine is different. I made it different. I wanted the velocity part so that I will do it.
This is velocity.
Yes, I've done it.
So Tariq, did you draw something here? Can you?
Sorry, it appears.
Okay.
I was manipulating some stuff here.
Yeah.
Sorry. Can you hear me?
Yeah. So you cannot delete it, right?
I don't know how to delete it.
Okay, you just know how to plot it, right?
Sorry.
It's a one way. Okay. Anyway, so Jacopo, are you done with that or?
Yes, I am set.
Okay, so and you can share. If some of you were not able to follow the comments and everything, then you can ask your friends to share their scripts with you, and yeah. But please try to read it and review the comments that you already learned. So probably tomorrow we can proceed faster. Thank you and see you.
Okay, thank you. Ciao.
Thank you.
Thank you. Ciao.
Simone.
Hey, Jacopo.
Yeah, how are
Hi,
you?
Simone.
Fine. Hey.
Yeah, yesterday we couldn't meet. Yeah.
We will meet
after
the short future.
Yeah. After the applied seismology.
Yeah.
Yes. You have to meet.
How are you so far in applied seismology, guys?
Bro, I'm still at lecture 7. I have to finish it. I have to finish it and rewatch all the videos again. But I will do it.
Stop plotting. I know you did. You watched all the videos.
Why don't you trust me? You know,
I know you watched all the videos.
Look, when I watch it for a longer time, then maybe it takes a long time for me to. I watch it maybe for some months. During the exam, I have to rewatch it again. So when you watch it closer to the exam, everything is just in your head.
Yeah.
So it's a strategy. It's a strategy. Just that you don't believe me.
What about you, Simone?
Yeah, I'm also reviewing the video of the lectures and
Okay.
Yeah.
Innocent, Kumsa.
They are not there.
They're already gone.
Yeah.
Okay, they are busy. Okay, ciao.
Yeah. So you have a lot of work to do, Tariq.
Huh?
You have a lot of work to do.
Which work?
Your exam will pile for you.
What?
I said your exam, it will pile up for you.
Which exam?
The earthquake, mechanics of earthquake.
Yeah, it's for the next week for me.
Okay.
Yeah.
Good luck, bro.
Yeah, thank you. Thanks.
Keep on revising it.
What?
Keep on revising.
I don't understand.
I said keep on revising your notes.
Yes, sure.
Yes.
Thank you. Ciao.
You're welcome. Bye. Small, bye-bye.
Bye.
Bye.